Hello, good afternoon. Goodness. Welcome to the stream. Lovely to see repeat visitors. Hi, Chris. Hi, Isaac. We're going to do something a little bit different today. I'm not planning to do Bevy unless we finish this task really fast. I don't think we will because it's going to be kind of intense. But it's been something that's been bugging me for a while. In the past few weeks, during work hours, actually, I've had time to explore this, to understand the problem, and I think it's pretty interesting. It like I think we're going to learn a lot about procedural macros. Um, I've done some in the past. Um, Ended up throwing that code away. It did not go to production. um, we also I've also done, on stream, I've done declarative macros, which are probably the easiest way to get in. Um, but um, we have a lot more power in procedural macros because they can do more than just syntactic substitution. You can really look at the structure of code, and they are how the hashtag attributes are implemented. Um, so so we're going to be looking at that. How derived macros are. This is, I think, this is not a derived macro. This is an attribute macro. Um, but let's get started. I'm going to try to give context at the beginning because this is going to get really, really intense, I think. And it's difficult to understand um, what the problem is. So I've tried to, and I did this for my own testing to try to figure out why the problem was happening. Um, I made a little sample project, so we're going to use that sample project today. We're going to look at cargo expand, which helps you, see what macros are writing, what code they're writing, um, and and yeah. So let's get started. Let's switch over to the coding view here. So we're looking at this issue on GitHub. Um, I found this issue as a result of searching for all sorts of issues at the intersection of two of my favorite crates, wasm-bindgen, which I kind of have to use in my day job, and tracing, which is the Tokyo project that lets you add instrumentation to your Rust code. And it can turn that into log output or distributed traces like OpenTelemetry or something like that, or just metrics. It's really flexible. So the problem is when they're used together, really. Um, and this doesn't look like it has anything to do with those two things. But what we discover is that similar problems happen when you run wasm-bindgen on a binary. So wasm-bindgen is the command line tool that takes the output of compilation and produces the bindings. So like the JavaScript code that will connect to the WebAssembly binary that you've created and expose it to your JavaScript application. Um, it's not strictly necessary on in some cases, but for the case that we're doing at work, the WebAssembly application is embedded inside a larger TypeScript and JavaScript application, and so we need to have those bindings. And it does some extra stuff that comes mostly from the macro that it implements. But this command line tool does a number of things to look at the generated binary, and it actually emulates the WebAssembly code. What I mean by that is the macro generates some functions that are only used in this like post processing step, and then the wasm-bindgen command line tool will set up an emulation of the virtual machine, the WebAssembly virtual machine, and call specifically those functions. And what those functions do is they basically just like put some things into registers or onto the stack or whatever, right? Um, and the interpreter is able to track that information and determine what it needs to do to generate the right functions. Okay. That's a hand wavy explanation, but it's very basic instructions. It's like, here's a number, push this number onto the stack, that sort of thing, or store this number into this local variable that has been declared. And by looking at the sequence of those variables that were declared locally, it does some stuff to figure out how to generate the functions. Anyway, again, that's very hand wavy, but the problem becomes, and I'm going to scroll down to, so this issue's about a unknown instruction block, and there's another issue. Let's see. Yeah, so the interpreter is intentionally limited. It's really only for the use case of these specific bindgen things. So some other folks are running into this. Let's see what this other issue is. So there's some other instructions that the interpreter doesn't support. And there's a closing. So they were talking about issues with WASI, which is another platform that you can compile WebAssembly for. We use the unknown, which is basically browser JavaScript. And people are asking to reopen it. So this is the comment that drew me to this. And this is what I ended up doing in my own code at work. We were using this tracing instrument macro, which decorates that function such that when you enter that function, a new span is created named after that function, and when you leave that function, that span is closed. So this is like the easy way to add instrumentation, and the answer, and honestly, their solution here is wrong. You can't really do this entered thing on async, but that's beside the point. Essentially, on all of our functions that were exposed via wasm-bindgen, I had to write let span equals blah 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 entered. Okay. What I would love is to just have this attribute on those functions that I want to instrument instead. Okay. Okay. So we get down here, about 3, maybe 4 days. It was a long time of investigation. I found out what is actually happening, and we'll see that in practice in a minute. So I thought the problem was tracing's macros. It was not. It was wasm-bindgen's macro. So when you and maybe we'll talk about the solution in a second. Let's look at the example code. So if you do something like this, so this is I made a struct. I want to expose it via the bindgen interface. So what that means is there will be a JavaScript class generated for this struct that'll be a proxy to the more primitive format that is inside the WebAssembly binary. And then I'm also generating an implementation. So if we ignore the tracing for a second, this says that this function should be the constructor on example. So if there's a constructor function generated for the JavaScript example class that's going to be generated, this will be the constructor. And then let's just, for example, let's comment this out real quick, because I want to show what happens when you compile this. What's going on here? Yeah, okay. we'll ignore that for now. So we're going to cargo build target wasm32 unknown unknown. And I should probably set this in the .cargo directory, but we'll skip that for now. Okay, so we're building, and okay, so we built a binary. If we look in target wasm32 unknown debug, you can see that I built this tracing wasm example.wasm. Okay, so now if we do, there's the wasm-bindgen command line tool that I installed separately. It has a bunch of options, and let's just pop that open. So what I would typically, the default is bundler. We don't need to do anything about that. Yeah, I think we can just use the default output right now. So we have to give it an input, and let's make, let's say the output directory outdir is dist, and then we give it the path to the binary, the wasm binary. Okay, so that was really fast, but if you look here in the dist directory, you see we get, so you can see we get a class defined in TypeScript. This is just some, let's see. Yeah, this is just some bindgen stuff. Here's some more bindgen stuff. This is where the meat of it happens. And you can see here that by having that constructor, this gets to be the constructor of example, and it calls example new, and does some pointer goop that's about tracking where that thing is in the WebAssembly memory. And then it returns a wrapper. So that's what happens in the happy path. And we can also, just for completeness, let's run cargo expand on this. And I'm going to need target wasm32. I don't know that this is strictly necessary, but just for safety. And I'm going to pipe that. This is also not strictly necessary, but I'm going to pipe it to bat because I want to make sure that it prints out correctly. Okay. So this is what I was talking about, these descriptor functions. This is one of the things. If we go down, there's going to be, you see there's a lot of things that say automatically derived. That's stuff that's generated by wasm-bindgen or by the standard library macros. Okay, so this is our first one. So we define the struct, and then it implements all these things for the struct. That's what that first wasm-bindgen attribute does. And it also, yeah, so it implements things that are about the ABI. This inform is sort of about information that it uses during bindgen. And then we go, okay, and then it implements a conversion between this Rust type into a generic JavaScript value. Really, that's, it's another wrapper thingy that's not particularly interesting. And then there's things about freeing it. Okay, so if we keep going, what we want to see is that function, that new function, right? Let's see. Yeah, okay. So there's some stuff here that's about what it was generated with. Okay, so here's our new function. It rewrote our new function. All this was supposed to do is return self, right? A zero-size struct. But it generates some functions that are used by the bindgen. So in this case, it creates this function kind of inside the same scope, and then it sets this link time attribute saying export this function as example new. Okay, and you can see here it's doing some stuff with those traits, and it says, you know, after we've called this, then, you know, turn it into the return ABI and so forth. And then there's this, which said this is the descriptor function. So this is what that interpreter will call, right? It'll say, hey, this is a function. There's 0 arguments. I'm guessing that's what it is. And I don't know what all these things mean, but and then it calls describe on the struct that it's returning. So you're getting the idea with these describe and the describe trait is that they are designed to be executed by the interpreter that is inside the wasm-bindgen tool. Okay. And here we're getting down to the end. Okay, so what we can do is let's put our tracing macro back on. Okay, and then let's expand again, and you will see that there's some stuff in here that shouldn't be there. So the tracing macro is its own ball of wax, and there's going to be some really swirly code. But if we go down, let's see, we're getting past all of the stuff that is about that binding. Okay, so here's our function new now. You will see that tracing has injected some stuff. So it's got the span, it's got a guard, and the guard is like when for the object that when dropped closes the span. It's checking the level filter. So if you're logging at, you know, like warn or error or something, it won't enter this section if you aren't. Okay, so here this is kind of weird. It's creating the span for this function. So you can see here it's got information about where this came from. So this is the file name, this is the line number, this is the target or the crate name. If this were inside a deeper module, it would be like the module name would be on here as a path as well. There's some fields that you can optionally set. We don't set any. And then it constructs the call site metadata. Okay. And it's doing a lot of stuff. Okay, fine. So here it's entering the span. You can see this is, if it gets through all of this, it enters the span and assigns it to this guard, which will be dropped at the end of the function. Now, we're going down in here. There's more goop. Okay. Here, this is the stuff that wasm-bindgen generated. Oops, now there's tracing stuff inside this bindgen function. This is the source of the problem. So if we look at, if we do build again, okay, and then we run wasm-bindgen again, oops. Let's see, that wasn't right. I don't know where my previous command went. Okay, after is dist, and then we're going to do target wasm debug tracing wasm. Okay, so you get this assertion failed address %4. So basically, it's like checking alignment. It's really that. If we look at the expand output again, we'll get down to the new function. If we look at the expand output again, tracing is being injected into those generated functions, and we don't want that to happen, because first of all, it's superfluous, but also wasm-bindgen doesn't like it. So what we would like to do is make sure that when and I want to make one thing really clear here. One thing I learned in investigating this is that attribute macros are applied from the outside in. So regardless of where this comes, and wasm-bindgen requires you to have it on this so that it knows what the type of this method is, like what it belongs to. Since this is on the outside, you can't like skip this, right? Or you can't inject it before wasm-bindgen does its work. Wasm-bindgen has already done its work. And this is really not the application of that macro, but providing additional information to the execution of this one. Okay? It's going to get wilder, I promise. So what happens is bindgen generates its stuff, and as it goes through here, it takes all of the attributes that are attached to the functions that are inside this input block and attaches them to the functions that it generates. Now, why would you want to do this? To me, at first I was like, this is insane. This is insanity. Why would you want to do this? But imagine that you had a config macro on here. And maybe you want to say this is only available for feature foo. It would become a compilation error to generate the bindgen functions and have them try to call this function when this function is excluded because this feature is turned off. So that's why. And we'll look into where that is. And hopefully you are still with me, and we'll figure this out together. But ideally what we want to get to is a way to say this function or this attribute macro can or cannot be applied to the functions inside here. So we want a way to filter it out. Okay, going back to the issue, I said, would it be useful to have an option for the macro that lets you filter out attributes with specific names? I could see that being straightforward to add. I say that it's straightforward to add. There is a direct way to add it, but getting the UX correct is going to be interesting. Okay, so one of the maintainers said it would be nice to do it the other way around. Only pass down specific attributes and then optionally include user specified ones. But I guess that would be a breaking change. Okay, so we have a couple of decisions to make here. I like his suggestion, his or her suggestion, I don't know, their suggestion that we only pass down specific attributes. So what would be safe ones to pass? The config adder. I'm trying to think of what other ones might be. Let's look at the Rust macros. Let's see. So obviously config, anything prefixed with config probably. So there's the config attribute, there's config adder, right? So these are things that you would typically set when you're trying to do conditional compilation. That's very useful. Let's see. There's only so far we can, or only so deep we can go. So like if they're using config adder, we can't guarantee, so like if it were something like this, we can't guarantee that these will be valid attributes on those functions. So that's kind of up to the caller, right? So we'll need to think about that. But I think config and config-attr are pretty reasonable ones because those are used in conditional compilation. Derive doesn't usually apply to functions, so we don't need to worry about that. Let's look at macros again. See if there's anything else in here that would be an attribute macro. That's not an attribute macro. Oops. Yeah, I don't think we need to consider any others right now. Okay. So let's go with let's just write real quickly here our plan. We will allow list, for lack of a better word, config and config-attr attributes, and then if we get through that, because that could be sufficiently complicated, we should have a syntax for propagating other attributes, allowing other attributes. Okay, so we'll start with looking at this. So let's go see if we can go to definition on that. Okay, so I have this open as a dual project, which hopefully should help us today. Okay, so this is so you can see here, this is in the macro crate, I believe. Yep, this is in the macro crate inside the wasm-bindgen project. And this is the entry point for this macro. So this is proc macro attribute. Okay, and then it's going to take the attribute itself and then what the attribute was attached to. These are both token streams, so they're like flat. There's another crate called syn, S-Y-N, which is used to turn those token streams into syntactic trees that emulate what the compiler does. So there's a lot in this wasm-bindgen macro support. Okay, so we should probably turn this on. Then it'll print out what it generated when we compile. We don't have to do cargo expand every time. So let's put that on in our cargo toml. Let's see. We'll say profile package wasm-bindgen, and features we're going to turn on. Let's get rid of the JS files here. I don't need those. This. So we'll turn that on. And just for argument's sake, let's build again. Yeah, I didn't print it. Let's see. Okay, we'll just put it in here. This is just an example project. We don't have to care about that. Okay, so it's actually printing out the tokens of the generated code. It's not going to look exactly like Rust syntax. Cargo expand is a bit better about that. You can see it's kind of smashed together, but we'll get printouts there. And I might even want to simplify this further. So that we have less goop to read through. Yeah, let's go ahead and simplify this further. This was to give an example that's like whatever my use case was like, but and int, let's do that, and it's going to return a U32. and it's going to return 42. Okay, so let's put these on there, except it's not a constructor. It's just wasm-bindgen, and it needs to be on the outside, right? That is part of the problem. Okay, so let's try it again. Okay, so now we're getting printed out a lot less. That's good. So interestingly, yeah, so you can see here on its exported function, this unsafe extern C, it's got tracing instrument added. So this is going to be before tracing instrument is called. It'll be applied there. And it's also on its describe. Yeah, and then that's not good. So let's see here. Let's dig into this now that we have that set up. Okay, so we're going to go into this function, wasm-bindgen macro support, expand. So this takes parsed input from the macro and returns generated bindings. You'll see this item fun, etc. These are types in the syn crate that that are like representations of what's inside the token stream. Okay, so they have this separate parser thing, which is a little bit stateful, and I'm concerned about that we might have to touch. But let's dig into this. So it's expecting an item, which is any top level construct, not lexical. So it's like you can see here things like constants, enums, an extern crate definition. Oops. Functions, foreign modules, impls, all the things that would be at a top level in a module. Okay. Okay, and then it creates an output token stream, and it goes into this stuff. So we should look at this. Yeah, let's look at this function. So this is a trait that they use to attach a function to syn items. Okay, so this is for syn item. If it's a function, okay, so this is where we want to be potentially concerned. We'll want to look at this type as well at some point. But let's focus on this first. So if it's a function item, right, and this is just about namespacing. So like if you renamed those crates when you imported them, wasm-bindgen or wasm-bindgen futures, it's gonna take that as an option. Let's see. We're not using that. I'm not sure what that does, but we'll see later. Okay. And then, so now is when we first get to the adders. So it's trying to figure out if the attributes on this function have the nomangle attribute. So this is similar code to what we'll want to do. Anyway, it's saying if there exists a the nomangle attribute, remove it. Okay, and then it's pulling out dot comments. And then it's adding allow dead code. Right, so it's saying it'll be unused when not building for the WASM target and produce dead code warning. Okay. So this is another case they're adding. We can see Where'd it go? Don't actually. This is just the tokens that it generated for its stuff. It doesn't show the whole thing. Maybe we'll want to use cargo expand still. Anyway, okay. So just to be clear, this is allowing you to not get compilation errors when something has wasm-bindgen attached and it's not called at all in your program. Okay. So let's see here. Then they're checking if there are generics, if it's the start function. So this is saying if you say wasm-bindgen start, this is a function that will be called when the binary is loaded. It basically sets a special export on that. So start function cannot have generics or arguments. We don't care about that right now. Excuse me. Okay. All right. So here's where the stuff is starting to happen. There is a method kind. It doesn't say what this is. Okay, so constructor or operation. It's just an operation. Is static true? Okay, so we should probably verify that this is actually what is being called. But there's a lot we haven't looked at. So I think that we'll probably want to look at this program type. So you see here it's pushing an export into the program, and it's constructing this struct which contains the comments and then the function, and this is another thing we'll look at probably. Right. So I think, let's see here. This impl, we'll want to look at this macro parse definition for impl as well. I think that that's probably where a lot of interesting thing happens. But this is the one for top level functions. If it's an impl first, then it's going to unwrap that and go into here. And we'll look at this. Okay. So then it's going into the items inside this impl block, and then let's see, it's just checking. Yeah, there's a lot of stuff here. Okay. Prepare for recursion. Right, so this is just checking a lot of stuff here. Okay. So here we're inserting attributes. Okay. So it's putting its own own stuff on here to be used later. Is what it looks like. Okay. So this is class marker for methods. And again, here it's like doing this exports push. So, right, in this case, you can see the Rust class is there. It's sum. So that's it's an ident, which is just an identifier that is going to generate a different kind of export. Okay. So let's look at this program type. And it's basically just a container for stuff. So exports, imports, link modules, enums, structs, custom sections, inline JS, and then like whatever the wasm-bindgen and wasm-bindgen futures crates are. Okay. Let's see here. So here's that export thing that was being pushed. Okay. And it doesn't tell us anything. Don't care about imports right now. We saw this on the other, on some of the other code, the method kind, operation kind. Imports, imports. Okay, we need to go back. Okay. So what I want to see is where an appropriate place would be, and I think it might be this opt things, where would be an appropriate place to say, like, let's filter to specific attribute types or attribute identifiers. And I feel like it'd be something like this, but I'm not positive yet that it would go right here. Okay. There's also this backend thing. I guess we've been down in there. This is the AST file. Okay, we just looked at this. Let's look in the cogen file. See if there's anything interesting in here. Okay, so there's this try two tokens. Right, so we'll look at this. See if there's anything there that's relevant. Okay. You can see this. We saw this earlier in the output. That's kind of interesting. Okay, try two tokens. So there's link to module. I don't need that. We don't care about struct right now or struct field. Here's export. Okay, this is probably gonna have some quote in it. Let's see here. Okay, so if this is a method, it's going to just have an identifier for that. That's interesting. Okay. Oh, right, because this U32 is a pointer into the WebAssembly heap. The WebAssembly flat memory, actually, it's not a heap, which is, just an offset. That's why this is an argument to this bindgen function. Okay. And okay, so they're constructing some pieces of this final definition. If it takes it by value, that consumes the receiver. Takes by mutable, it calls a different function. Shared takes a different one. Okay, and if there's a class, then it's going to say, what is this? Okay, so this is like there's no self argument. So this is a class or struct level function, and it's got to be prefixed with the double colon. Okay. Um, Otherwise, it's just a function. So this is constructing the call to the to that function that we are binding. Okay, and the arg types. Okay. Nested types. That's okay. I don't think we need to be caring about that right now. Let's see here. Okay, this is converting those types from their JavaScript representations. Okay. Now let's get down to so async, it's got to do future to promise. Don't care. Okay, so here's the actual call. So it spent all this time constructing the receiver and then constructing the arguments, and then it's going to, have a name for that variable, and then whatever it needs to return. And then so if it's a start function, it calls this spawn local on wasm-bindgen futures. If this is async, right? Otherwise, it calls future to promise and does async move and then puts the call inside that. So again, we're building up. This is the stuff that gets ugly, unfortunately. What I'm looking for. Okay, so here we go. Here are the Rust function attributes. And you'll notice that they just get splatted right here onto this generated function. So I'm wondering if this is the spot where we should filter. I'm thinking it's not. It might be too late in the process. What we should do is probably do it up here in the macro support crate. Sorry, not the macro crate, but the macro support crate. Well, somewhere in this parser file. I think that's probably the correct place to put it. Okay, let's look at this trait. Oh, okay. And if Chris, I know you've done some stuff with this, probably not this specifically, but probably going to lean on folks in the chat if you're there, if you've done any proc macros. I'm a little bit nervous about it. I won't lie. But we're gonna see what we can figure out. Okay. I think that we can rule out we don't care about item enums or const or foreign mods or foreign items module from ops. Let's see. Yeah, that's about linking to JavaScript modules in imports. That's what that's about. Okay, don't care about that. Interesting. Dot comments. Unescapes a quoted string. We probably don't care about that right now. Escape Unicode. Assert no lifetimes. Don't care about that. Probably don't care about that. Interesting. This might be something we need to look at. I don't think it's there, but what is attribute parser? Attribute parse state. Okay. Right. Operation kind. This is getting us that. Is it is it any of this? So it's either regular or it's a getter, setter, indexing getter. Okay, so those are for exports for particular methods. Link to. I've never used that. Okay. I'm assuming that's where you have another binary, WebAssembly binary, and you want to be able to call functions in it, but you're not responsible for loading it. Or linking, or rather compiling it into your same binary. So I don't think that we're concerned with that. We don't care about main. Let's look at that. What that is. Yeah, real quick. Main. Okay, so this is like, I think if you were building to be a standalone, you would probably have a main function rather than a startup function, and that's what this is. But we're not using that. Okay, and the rest of this is tests. Okay, so let's go back up to the top. See if we missed anything that is important. Okay. So this is interesting. Here's where we might be able to add an attribute when we get to that. That is a weird macro. Okay. See, methods. Yeah, I don't know. I've seen proc macros for low-level embedded crates for entry interrupt, but I didn't understand them, so can I really help? Well, thanks for offering, Isaac. This is really about learning. I'm gonna see if we can do it in the next hour. But so far we've mostly just read code, which I guess is like most of the work. Okay, so this is about taking sin attributes and then finding and parsing the wasm-bindgen attribute into this struct that we saw up above, which is a vec of I don't know what this cell bool is. We'll find out. And then one of these things in this enum. So we'll probably see this enum defined in here. Yeah, it's in this file. Okay. Okay, so it creates a default one, and then it's looking for attributes that start with wasm-bindgen. And if it finds one, it removes it from the collection. Okay. Yeah. Okay, and then so there are different kinds of attributes. Let's see. So path is like the test in test. So if it's just wasm-bindgen, it'll become, oops, show me that. Okay, it'll be path. So if it's just flat wasm-bindgen, it'll be path. Name value is like that. That won't be a case for this. And then list is like derived copy in that. So it'll be like parentheses and then some stuff inside, which is how wasm-bindgen does it. And then it's expecting the delimiter to be parens. So if it doesn't use parens inside there, it's going to blow up. Okay. Check used. Hi, is this editor good? I never saw it before. Yes. Welcome, first time chatter with a very interesting name. I can't tell if that's a color code or not. This is Z preview, the preview channel. You can get the stable version too, but I've been loving it. I used to be an Emacs weenie, and you'll still see it on my stream when I pull up my to-do list. But yes, I've been enjoying it a lot. It is responsive. They're really good about updating things on a regular basis, and they also have a pairing type of thing. So on my stream before, we've done, my friend Quinn joined in. I think it was in August or September, and Quinn typed into my editor from California while I'm in Kansas City. So it's pretty cool. And we didn't have to do any screen sharing. It was just like you connect, and it's like a GitHub profile lookup type thing. Anyway, it's very cool. I recommend it. Obviously, it looks kind of like Duplo blocks right now because I'm doing, yeah, time does fly, Chris, because I'm doing this at a lower screen resolution. So it looks a little bit simplified. These would not normally be this big. I don't know a way to change the text size of the UI, but you can change the text size of the buffer, so it's fine. It's just a little bit chunky. Okay. Right. So let's go down and look at parse. Okay. So interesting that so when you're parsing it out of this parse stream, it takes each of the options right, and then it's expecting, so this is punctuated bindgen adder comma, and then it's going to put that. So I'm guessing this cell new false has something to do with whether it's been used or not. We will find out. Okay, so remember that macro we saw up above? This is it. Possible attributes in wasm-bindgen, and this is all the variants. Okay, so let's look at this one. This looks at the parse stream. So this is recursing in. It's trying to parse the contents of this set of options. As you can see, this is bindgen adder. So here it's implementing parse again for bindgen adder, as well as it did for the collection of them. Okay. So looking in here, I don't know what fork does. Is that like a clone? Oh, right. Okay, so this is forking the stream. Okay, so we've got some crazy declarative macros here. Okay, so each of these things is a name and a content. So this is the thing that we saw above, I think, with the adder-gen, where it's the name that it's the identifier it's expecting in the attribute macro. So this would be like if we have wasm-bindgen, and it's like constructor. It's turning this identifier into one of the variants of this bindgen adder enum. So right, so you look here, you could say constructor, and then it gets a span, which is like where in the code that where in the original code that identifier was. That's that sort of thing. Or you could say like JS class equals foo, and that would go to this one. So you see it's a span, an identifier. It's expecting a token, and then it parses. I don't know what that, oh, any identifier. Okay, so the any identifier would be like that foo. It could be could be a string. It could be a bear identifier sort of thing. Okay. And this is for one where the variant can take an optional identifier. I don't remember which ones those are, but okay. Let's see here. If it's a path, looks like it's expecting a token again. The equals token. Okay, so these are the different kinds of attributes that can be parsed out. And then it's got some recursive macro goop. So it calls addergen on the list of parsers. So it's basically it's calling this addergen way at the top. Where did it go? Here it is. So it's basically saying these are all the attribute the identifiers you can put inside the wasm-bindgen attribute, and then it will call whatever macro you pass to it with this information. So okay, so we've got macros on macros, which is yuck. Okay. Interesting. Okay, where were we? Right. Okay, so this any ident is just a wrapper type for accepting any kind of identifier from the stream. Okay. Okay, so convert to AST we can use to generate glue code. Okay, and that's arbitrary over, that's generic over context. We don't care about mstruct. Was there a GitHub for the issue? Can you link it? Yeah, I'll paste it in the chat real quick. It was this one. There you go. If it'll let me paste, come on. Copy. Paste. Well, that was way too hard. There you go. Okay. Program import module. I think this is, we don't care about that. Program not for an item type. Import module. Nope. Item fun. We care about this. Function from decal. Non-const public functions. Okay. So we'll want to look at this function. Right. Okay, so this check used. Yeah. More declarative macros. Basically, they're making it so that they don't have to duplicate the variants everywhere. Right, so this is what that cell is. It's tracking whether the attribute was used. I'm guessing so that like on items that aren't, like, that attribute is not relevant. Say for example, you have it on a top level function, you give it a JS class attribute, that's not going to be relevant for that, so it's not going to be touched. So excuse me, let me revert all the changes here. And so, yeah, so that's why they have that cell in there in that list. Okay, so let's look at this function. Construct a function gets a self-type appropriate for our AST from a sin function. Okay, so sin being the crate that defines the Rust AST. Okay, it can't be variadic, or I think by what they mean by that is have impl as an argument, or generics, or return position impl um, and no lifetimes. Okay, right. So those are arguments. The output is the output type, return type. Okay. Arged typed receiver. So this is collecting the arguments, collecting the output type, and then operation kind. Right, so that was the yeah, if it is it a setter, is it a getter, is it an indexing operation? Yeah. Okay, so this is generating a name for the function, I'm guessing. Right, and then it's returning this AST function. Interesting, this doesn't, okay, so there's the Rust adders, and let's see where that adders comes from. Is it an argument to this function? It is. So these are the other attributes on the function. I think what I'm trying to get to here is where do we handle filtering those attributes? And I want to say it's going to be in this macro parse implementation, not in this code gen. Right, because this is going to, let's go to that definition. This is just the any custom attributes apply to the function. Yeah, I think it's this is constructing the AST, so that's not, it's not what we want. It is relevant, but it's not what we care about. Right. So this function is that, yeah, maybe it is in the code gen. I'm just concerned that we need to get that information in here somewhere about like what is a permitted attribute to apply to the generated functions. So maybe it's just in here we do it brute force first. I'm sorry I'm being like really wishy-washy about this, but there's a lot of code here, and I want to be really careful about which things I change. So where was that spot where we saw them just splatting the attributes in? I think it was down here. Right, we even have it highlighted. Okay, so this might be a place because this is a generated function, we could let's make a new variable. Let's say safe adders, let's call it. And let's say self.function.rust adders filter. We're going to have to do iter. Yeah, not into iter. We just want iter. Filter. Okay, so this is going to be an adder. This is a vec of attribute. So let's look up. I don't know if I have the syn crate installed here. Let's see. Syn generate, and that's probably going to take a minute. There's a lot of structs in that crate. Okay. In the meantime, let's see if we can use the inline help there. So if this is a attribute, right? Syn attribute. Okay. Let's look at fine dot collect vec. Okay, we're just going to say true here. That needs to return a bool. Fine. Don't want to fight the compiler too much. Okay, so that's a reference to a reference of an attribute. Interesting. We probably want cloned here. We'll see. Okay, then it's just a reference to the attribute. That makes a bit more sense. And this is probably like unused. Yep. Okay. So what we want to know is see if we can see what. So I think it's maybe path. What do we do in that other place? I think, let's see, adders, find. Yeah, here we go. m.path.isIdent. So we probably want to do something like this. Okay. So we want to say a.path.isIdent. We'll do it like this. Let path a.path path.isIdent, and we want to allow config or path.isIdent config adder, which is what we talked about earlier. What's wrong here? Okay, so it's still unused. So now if we say safe adders here on the exported function, and then where's the describe function? I think we have to go farther down. Okay, the descriptor, so we want safe adders clone. Actually, that clone might be unnecessary, but we'll see. I don't know if you can hear in the background, but my wife is watching the football game and having a great time. Okay, so let's see. There's a lot. Interesting, we're not using that anymore. Okay, that's an interesting discovery. Let's change that to adders. Right? What's going on here? Unnecessary eager cloning of iterator items. Okay, let's remove the clone. Thank you, Clippy. You are very helpful. Okay, so this requires, yeah. So we're going to have to do, I think this would be like into iter cloned collect all the warnings. Interesting, like wasm-bindgen using edition 2018. So we're probably not going to get some things. We don't care about that. That's not us either. Yikes. Okay, that's not us. So what I want to do now, let's look at their cargo toml, because what I want to do is build I think we have to build CLI, the CLI crate. Yeah, source bin. Okay. So we're going to go in here and we're going to build the CLI crate, as well as dealing with the bin wasm-bindgen. Let's just try that. P CLI. What are you talking about? Bindgen CLI. Okay. So we'll see if this works. Okay. So I think that now that we've tweaked that macro, we're probably going to get different output here. So hopefully what we should see is when we run this, we're not getting tracing instrument attached to this describe function or to the exported function, the interface function. I don't know if a better word for it. If we didn't blow it up. Okay. So we don't. That's pretty cool. Now let's see if we can run the bindgen tool against it. Target debug, right? Outdir dist, target wasm32, debug. Okay, so we generated that again, and that happened just now, right? So we know that the tool's not broken by our output. Let's make a quick test here about, so you see the tracing instrument didn't come through. Let's put a config feature is foo, and then we need to put that feature in here. features, default. Let's just say foo is empty list. And it's probably not going to like that, but okay, so now when we run that, we should get nothing in the output. Yeah. Oh, that's interesting. It exported it anyway. Did we get... No, we didn't get any output when we built, right? Just because it wasn't... the macro wasn't calling there. I wonder if it didn't output anything because... we might need to look at the WebAssembly text output of this to see what's in there. We could also run cargo expand again, so let's run cargo expand. There we go. See what gets output. Interesting. Let's keep going. That I think I probably need to set default features as empty. Let's see here. Is it defaults or is it default features? I think it's just defaults. I think it probably assumes that it's enabled if you don't. Interestingly, those config attributes are not being attached to this, which is not good. And look at where they're put. They're not inside the function like they were before. So I messed something up, because they should be inside this function. It's not really... Okay, so let's go back to our code gen, and I think I don't fully understand all of these things here. I'm curious about whether okay, let's comment this out for now, and let's put adders back in here, because we want that config to come through. And then we'll do, let me put that on in a comment and say adders.clone. And okay, so we're getting the tracing instrument, but we're not getting the config. Maybe that was part of the problem. Did I... Yeah, so like, oh, well, helps if I save. uh, it helps if I save. Okay, let's go back to our code. Such a bonehead move. This is what you do, or this is what happens when you do live coding, folks. Okay, so we're gonna try this again. Um, now that I reverted those reverts. Okay, so I have a problem in my source code. Helps if I put that in there. Okay. Okay, so now it's not outputting that function at all, which is exactly what we want. Um, but if I say, if I add here features foo, I should get all that good, right? So you can see config feature foo is being attached to that function, but tracing instrument is not, which I think is what we were trying to go for. And you can see our tracing is being injected here. The config feature foo is still on the outside. I'm a little bit concerned that our change ended up putting this outside the implementation of that function, because I thought it was injecting onto the inside of it. I suppose it's not that much of an issue because this expression, I suppose that's okay to have at the top level. It's not like it's complaining about compiling it, right? Cargo build. Okay, it's just, we've got that feature turned on to print out the macro stuff. Um, yeah, I think that's okay. I want to turn off this feature. I think it's not that useful right now. We'll use cargo expand. I think that's good enough for us. Okay, and I want to try one more possibility here, which is where did it go? Here. We're going to put in it's a bit more complicated. We'll do this again. Let's put wasm-bindgen on that. Fun t self. I don't know. We'll just say new. And we'll do the inverse here. And let's put wasm-bindgen constructor on this. So fine default. Make Clippy happy. Okay, so let's run expand with the feature on. Okay, and so we get the anint function. We get the struct, which gets a wasm described for it, and all that stuff that we expect to see. But we should not get its constructor fun. Oh, man, all the stuff that it has to output. Yeah, see, you can see the impl example, there's nothing in there. Okay. And if we remove that foo feature, we should get um, okay, so interestingly, I guess maybe it's not on item funds, but only on methods inside impl blocks that the bindings get injected in, which I guess makes sense because the const and the inside the impl block would not be correct. Um, okay, so we can see here that, you know, in this case, it's probably not strictly necessary because, but like the macro doesn't know. So this will get emitted um, on that. Okay. This might be good enough to make a patch as a proof of concept and get feedback. So I think I'm going to go ahead and do that. Um, so looking at this, yeah, I think this is a good place. So, and I need to make a fork. And then we can, let's see, fork. And there, copy the main branch only. Cool. And then let's see. Let's get that remote set up. Okay. Add mine. I think I'm gonna is it -m? Is it rename? Oh, it's rename. Rename origin upstream. Okay. I'm gonna rename mine origin. Then I'll always be pushing to my own. Let's make a branch and going back here to this issue, we want to reference this issue, so number 3315. So let's call it filter. Let's call it filter safe. Macro filter safe attributes. And then, okay, so it's already added. Let's make a commit. Filter attributes on bindgen descriptor functions to safe ones. What is up with the iter cloned collect? I'll go back to that in a second, and I will answer that question, Isaac. That's a great question. Number 3315. And we'll make a more detailed thing when we make a pull request. Okay. Okay, so we made a commit. You wanted to know about the iter cloned. Okay, so it has to do with this. So adders is a reference to the vec of attributes inside self, right? So when we're creating safe adders, this is a mutable reference. We create an iterator over it, then we're filtering it, and the items inside this will be references to the attributes in the original vec. So I was doing .cloned here originally, and then Clippy's like, you don't need to do that. Now I could say, let's comment this out and say self.function.rust adders. And I think it would still, it still returns a vec of references to attributes. So the problem is down here. Now that we have this, we're trying to move this vec of references to attributes into this descriptor struct. And the compiler can't tell whether self is going to live longer than this descriptor. So it can't say that those references to attributes will always be valid. And so what we have to do is, and this needs collect. Sorry, I undid that by accident. So we basically need to go through and clone all of the attributes from the original. Yeah, that's what I maybe cloned after the filter. That's what I had before. But I mean, maybe we can go back and do that up here. Say filter cloned. But I think it was saying it doesn't need to be. I'll let Clippy finish there. Yep, no problems with that. That's a good call. I think I was doing cloned before the filter, but cloning after the filter is going to be more efficient. Good call. Okay. Yeah, another way we could do it is filter map and, have an if in here, that sort of thing, with the clone inside. But Clippy would probably tell us, you're cloning inside that filter map. You could just do .cloned. So we'll see. Okay. Yeah, that looks good. Let's see what the diff is on that. Yeah, I think the only time that we might not want to do that is if there's anything between these two spots where we might just throw away that vec, and then we can avoid cloning each of the attributes here. But honestly, in this sort of thing, I'm not that concerned about efficiency. So this is probably fine. Let's just amend that. Oops, helps if I add it. So there we go. And here, this is interesting. Inside the quote, it doesn't have, this is not moved inside the quote. So I think this, this iteration here is like calls .iter rather than .into_iter, so it doesn't consume it. Okay, so I think that's good. If we look at our plan over here, we did 0.1, and the next step would be to do this one. And I think where a good place to stop would be is here for today. I'll submit a draft PR perhaps, looking for feedback. because I think that if we're in the complete wrong spot in the code base, um, then, or if this is like, this is a direction that other maintainers don't want to go, then I want to know sooner rather than later. And we can pick this back up at another time, adding this syntax for allowing other attributes. However, I think it might be wise to make a test. And let's see where that would be. Tests. Okay. So let's look at some of the files I have in here. I don't know if you all have seen this try build. Um, yeah. So this try build is a way to test compilation. It's pretty cool. I've used it before. So this is saying compile will fail for all of the things in here. I don't think that's what we want to test though. Let's see if there's something in macro support. No, I really think it's probably macro where this belongs. Let's look at one of their example tests. So missing catch, this returns JS value. Yeah, okay. So that should fail to compile because it returns JS result, JS value, and it's not catching an imported function. Okay, let's maybe see invalid methods. Wow, I've never seen that. Is that actual syntax? Interesting. Okay. Doesn't allow const funds. Yeah, so you can see here, this is what it should look like. Default impls are not supported. I've never seen that syntax. That was wild. Yeah, still weird that Clippy triggered at all. The clone wasn't needed for filter because it takes by ref, but the clone should impact the collect. Yeah, I agree. I agree. It's so good. Hello, Mitch. Welcome back to the stream, Mitch. Okay, so yeah, it can't bind gen on trait impls. You can't bind gen on references. Const definitions aren't supported. Okay. Show me your game. Well, we're not doing the game today, Mitch. I mean, it kind of sucks right now, too. How many A's? 0 A's. There are 0 A's. It is a triple Z game. Yeah, I really want to make a test for this, but it won't be... It won't trigger an error, right? Something to think about. Let's look at what's this test macro. Maybe this is where they go. UI tests. That's all compare. Create. Okay, that's interesting. Ignore. Malformed ignore attribute. Okay. Should panic. Oh, this is the wasm-bindgen test macro, not tests for the macro. Okay. So, yeah, that's probably a good place to stop. We are not getting any farther here. I really would love to have a compile test for this. I'm a little bit concerned that the way to test it is not just like compiling the output, but also making sure that the CLI support works, because that's where the original problem happened. It just doesn't. The CLI does well. It has a test here. Let's look at this. Main. Okay. Currently is a bit running cargo build at test time, which is quite expensive. So the test doesn't become too large. Okay. That makes sense. Right, so it's running cargo. And then running... Okay, so this is a wrapper to build a project. Okay. Okay, it works on empty project. Yeah, maybe this is where we want it to go. However, we're going to need somewhere in here a macro that does goop to the bindgen functions that it won't like, and reproducing that is a little bit tough. Yeah, because we want it to generate operations that the interpreter. So this is this like deep rabbit hole that I went into to figure out why it was broken in the first place, and then now we have no way to test it other than manually testing it. Pretty frustrating. This might be a place to be doing it. Okay. Well, let's go ahead and push my branch to my fork, and then we will open a new PR. Okay, I'm going to put this in here. I'm going to say apply, do not apply unknown attributes to generated functions. And we'll put in a little description here. This is just the commit message, so is a response to 3315. And where did that issue go? Okay, and I'm going to refer to this. Okay. And what was that user's name? Dax Peta. Okay. Dax Peta suggested that we pass down specific attributes and then allow the user to specify additional macro attributes that could be attached to the bindgen, the generated, how do you say that, to the bindgen, and descriptor functions. This is an initial implementation of the first part of this idea, namely that only the config and config adder attributes are allowed to be passed through. There may be others that should be allowed by default, but since these are involved in conditional compilation, I felt they would be most relevant to pass down, to apply to the generating functions. I'm mostly looking for feedback on the direction here before I dive too much deeper. Thanks. Create a draft pull requests. I'm going to say do not apply attributes blind. Say apply only allowed attributes to generated functions. And here I want to link specifically to that. So we'll make a link here. That. Okay. Submitted a PR. How about that? Okay. By popular demand, or rather, Mitch just bugging me, we're gonna fire up where our game was last time, since you're being a putz about it. Thanks, Chris. Thank you. I appreciate it. Okay. So, Mitch, you wanted to see what we're building. Let's run this. Oh, Rust Analyzer's busy. Give me a second. So busy. Okay, it doesn't do too much yet, Mitch. It doesn't look too great, but here we are. We got a survivor's game. Our character moves faster than the knives he throws. Go figure. The knives kill ghosts. And when we get over to the side here, and this is the part where we left it last time, we bump into the side of the screen and go wonky. So that was fun. Okay, you got to see the game, Mitch. You're welcome. Okay. All right. Well, thanks everybody for coming today. I feel like I spent most of the time talking and reading code, and we didn't write that much, which is probably good for this sort of thing. The whole system of macros is big and complicated and easy to break. So I'm glad that we were able to scope the changes to something really small. Um, Hopefully by next week we'll have some feedback on that PR. I have some doubts that we will, because that is such a busy project, um, with maintainers who don't have a lot of time to spend on it. So I have doubts. Um, Obviously this sort of thing is a breaking change, so they're probably loath to do it. But at the very least, we can get some feedback, and then maybe in the future, we'll be able to, um, have support for things like tracing, without the user having to do their own handling of that sort of stuff. So, using the macros that tracing provided, as well as anything else that might have been used, in that sort of situation. It just so happened to be that it occurred for me with tracing, the tracing macro. So thanks again for coming, and hopefully we'll see you next week. Some of you probably have tomorrow off. Enjoy your day off, if you do, and I'll see you next time. Thanks for coming, Isaac, and thank you again for all of your great questions. Cheers.